Alright Swifter, it's Prof J, and we're going to be parsing JSON data in Swift using Codable. We're going to create a subclass of our weather location class, and we're going to create custom structs to parse complex nested JSON. Let's giddy up. Now our app can get data, good job, but right now it's just printing a big blob of output to the console. We got nothing in our app from the dark sky data. There's also way more data than we'll be using in our app. So what we'll be learning in this video is how to parse or filter out and extract the elements of this data that we need. And this data is formatted as JSON. So we're going to learn how to parse JSON formatted data. Specifically, we're going to extract time zone, which is up here, current temperature, which is inside this currently guy here, and also way further down, not in minutely, not in hourly, but in daily, we're going to get this summary field, which is the daily weather summary. And while we're learning how to parse JSON data, we're also going to be learning about subclassing. Now, a subclass is a class that's based on another class. It inherits everything from its parent class. Parent classes are sometimes called superclasses. But in addition to all that superclass goodness, the subclass also contains its own stuff, additional properties and methods. Now, we've already been subclassing. Whenever we've created a Cocoa Touch class as our starting class, and we've done this with UI View Controller, UI Table View Controller, UI Table View Cell, and UI Page View Controller, and then we added our own stuff on top of it, we're taking an Apple-provided superclass, and we're creating our own subclass, where we're adding our own stuff inside of all of Apple's goodness. Now, sometimes the phrase subclass can be confusing, because sub normally means less, but a subclass typically has more methods or properties. Now, we're going to be subclassing our weather location class. The reason for this is that we want to keep weather location to save the coordinates, the latitude and longitude plus the place name for our device. This guy is just right, Goldilocks for saving and loading. But now that we're getting weather data, we're going to be getting lots more data. And this weather data is stuff that we don't want to save to the device, since the weather may change every time we swipe left or right. Weather is constantly fluctuating. So we're going to get the weather data each time we update Location Detail View Controller. So we'll keep weather location as the superclass that we save, but we'll create an expanded subclass called WeatherDetail. Now, a subclass is super easy to create. We just follow the class name with a colon and the superclass name. That's it. Then we can put in all of our subclass stuff below. So we're going to move our getData method that used URL session to access dark sky from our weather location to our new WeatherDetail subclass. And that new subclass is also going to include all of the extra data structures to hold the weather information for us to display in our app, and the code needed to parse out that big wad of JSON that we got back from dark sky. Now, we also have a few options when creating an instance of a subclass from an instance of a superclass, but for now, we'll just use this one. We'll take the same initializer that's part of the superclass, but we'll call it using the subclass's class name, the type, and we'll pass in the parameters that the initializer needs. And we can do that because WeatherDetail is a subclass of weather location. It inherits all the weather location stuff, including this initializer over here. Let's do it. So back in Xcode, I'm going to create WeatherDetail below weather location. So I'll right-click on weather location, select new file. It's a Swift file. We're not subclassing one of Apple's Cocoa Touch classes. We are subclassing one of our own classes. So click next, name it uppercase WeatherDetail, click create. And we'll declare the class like we've done all others before it. Class WeatherDetail, which is the class name, but here comes the subclass goodness. We follow this by a colon, and then the name of the superclass of weather location. Open and close curlies, and this means create the WeatherDetail class so that it's got all of the stuff inside of the weather location class, the weather location blueprint, plus anything else we add below. Now, since weather location is just going to focus on holding the 3 values that we save and load, we'll cut out the stuff that accesses the weather data and move that over to WeatherDetail. So click weather location, highlight the entire getData function, but make sure that you leave the closing class curly, cut it out with a Command X, return to WeatherDetail, and paste it in with a Command V just before the WeatherDetail close curly. Now that we've got WeatherDetail set up, let's return to Location Detail View Controller and make sure that now we call the getData method from WeatherDetail and not from weather location. But we don't yet have a WeatherDetail object, so we'll create one right under weather location here the same way. So we'll say var WeatherDetail lower camel case colon WeatherDetail upper camel case, and we'll make that an implicitly unwrapped optional with an exclamation point at the end. And so we'll initialize WeatherDetail down inside of Update User Interface. So just below where we initialize the weather location, we'll say WeatherDetail equals upper camel case, weather detail, open parens. And now check out what we're looking at. We see a weather detail initializer with 3 parameters, but we didn't create an initializer for weather detail. Where did this come from? We inherited it from weather location, the superclass. So it's that class's initializer. We can create a new weather detail by passing in the same 3 values. So press return to accept that, and then we'll leverage the weather location we created just above this by saying name is weatherlocation.name, latitude is weatherlocation.latitude, and longitude is weatherlocation.longitude. And then Xcode helps us find out everything else that needs to be changed. So here, placelabel.text will now equal weatherdetail.name instead of weatherlocation.name. And down here, instead of calling weatherLocationGetData, it's weatherdetail.getData. So if we scroll down, we don't see any errors in red. So now you can build and run to make sure that everything works. That means that we have successfully created a subclass of weatherLocation called weatherDetail. We've moved over getData. We're able to call it. Our data shows up. Nothing else changes in the executing app. There's something else we can do to clean up Location Detail View Controller, though. We only refer to weatherLocation and weatherDetail in our update user interface function, so we actually don't need these 2 values to be class-wide properties. And before I make that change, I'm just going to verify that that's the case, although if I did something wrong, Xcode will show me a bunch of errors. So I'll just find all the occurrences of weather locations in my code. So I'll press Command F to open Find at the top of my code window, then enter lower camel case weather locations in the Find box. Press return, and I see all the weather locations highlighted. These ones in update user interface are fine, and in fact that's where I'm going to change this to be a local variable with function scope instead of a class-wide property. And now down here in prepare for segue and unwind, I don't need to worry about these either because these are just swapping values between the page view controller and the destination or source, which is the location list view controller. So none of these are using the weather location property defined in this class. So I'm just going to go up here to this property up top, highlight weather locations and delete it. Then down here where I first used weather location, I was initializing a variable that's already been declared. I'm just going to declare it right here in update user interface. And of course you know how to do this. You just put the word let in front of weather location. And I'm going to do the same thing with weather detail below it, turning it into a constant with function scope as well. And instead of searching for weather detail, I'm just going to go up top and delete the class-wide property weather detail. If there was a problem, Xcode would show me errors. I don't see any. We're good. If you want, you can build and run to make sure that everything works fine, and it does. As we swipe through our app, we're accessing JSON for each location. Good. So now let's get to parsing this JSON. Now, if we look at the web output from Dark Sky, I'll highlight the values that we want. Let's first get time zone here. We're going to use that later on when we convert dates, but I'm also going to get it now even though I'm not using time zone yet because I want to get something that's at this first level of JSON key values. These values at the first level are the easiest to parse out, and so that's a good place to start, and we've already got longitude and latitude. Then I want to get the current temperature, and that's nested inside of this guy named currently. And then to get today's weather summary, we got to go way down here. So I'll collapse minutely, hourly, and the summary is inside this guy named daily. So how do we parse or extract those values? Let's see. So as we've been saying, this data is in the JSON format. Now, JSON stands for JavaScript Object Notation. It's the most popular format used by APIs. It's an open cross-platform data standard. It's used everywhere. And JSON organizes data in key value pairs. These are sometimes referred to as name value pairs or attribute value pairs. The key is the identifying string enclosed in quotes, and you can consider the key to be the name of the data or value that comes after the colon. Now the values can be most common data types. They can contain text, numbers, booleans, raw data, or even other nested key value pairs, as well as arrays. Now we need to turn subsets of this JSON over here into Swift variables, but fortunately Swift makes it super easy to turn JSON into an object or a struct. All we need to do is to create a struct or a class that conforms to Codable, and that struct or class has to have the same property or variable names, same case, same spacing as the JSON keys that we're trying to match it with. And as long as the JSON is of a type that's compatible with these properties, strings to strings, numbers to numbers, we can use a decoder to automatically go through all of our JSON and pick out just the stuff that we want, assigning it into the properties of our struct or class. So let's see this in action. So this code shows how we're going to do this. First, we'll create a struct inside our weather detail class. We'll call that result, and this is what will eventually hold all of the decoded JSON data from Dark Sky, and we'll make it codable. Now inside of getData, we've already returned data. It was one of those 3 values, data, response, and error. So now what we're going to do is we're going to use this line to decode the JSON into a result struct and call this lowercase result. Now time zone is at the first level of our JSON, so we can get at it just by saying result.timezone. Now getting temperature here is going to be a little bit trickier. It's inside of currently. This is a key whose value includes several additional key value pairs, but it's not that tricky. Each nested set of key value pairs requires just another struct, once again with the same variable names as the keys. So to get to temperature inside of currently here, we're going to create a struct called currently. This is going to be a new type, so capital currently, upper camel case. Now all these new structs that are going to be used for decoding also need to conform to Codable. And this new currently struct that is Codable will contain a temperature variable that's a double, same name as this key here, and we'll add a value to our result struct up top here that is lowercase currently, that's just like this key, that is of type capital currently, which is the type for this struct down here that can parse out our temperature. Then to get to the temperature, all we have to do is say result.currently.temperature. Now once you've got this pattern down, the rest is just wash, rinse, repeat. So summary is inside this set of JSON that's nested inside of the daily key, just like temperature was inside of the currently key. So what we'll do here is something similar. We're going to create a new struct called daily, capital daily because it's a struct. It will be codable. It will contain a value called summary, same exact variable name as this key here, and we'll create a new property in the result struct called lowercase daily that is of type capital daily. That's this struct here. And then how do we get the summary? Just result.daily.summary. Let's build this. So back in Xcode, open up our WeatherDetail class. Let's create that result struct right under the class definition. So we'll say struct capital result colon codable, make it codable, open and close curly, and inside we'll put in our first variable that we want to get. That's going to be time zone. So we'll just say time zone colon string. And again, you need to be 100% certain that you're spelling the variable time zone the same way that the key value time zone is spelled in your JSON. Now let's go down into our getData method, find the area where we deal with data. That's our do, try, catch right here. And we're going to replace this JSON serialization. I'll leave it in here now just for comparison. But right after that, we'll say let result equals try JSON decoder, open and close parens, dot decode. Select this right here. You can see that it throws, so that's why we're inside of a do catch. And then for the first parameter in here for the type, it's a syntax we've never used before, but we'll say capital result, which is the type we defined above, dot self, then tab over, and from wants data. That's going to be lowercase data, force unwrap with an exclamation point. Remember, we got our data from up here. It was being returned from our data task. Data was part of the data response error, triumvirate of possibilities that comes back from the session data task. And now right under this, instead of printing out JSON, let's go ahead and print out result. And then I'll put another print statement down here. And why don't we say this is going to be the time zone is, and in string interp result.timezone. In fact, even better, how about the time zone for string interp self.name is string interp result.timezone. But you might say, hey, wait a second, self.name, there's no name inside of our weather detail when I look up here to where our properties are. But remember, we inherited everything from weather location, and weather location has a name which is a string. So we can refer to that because weather detail has all of the properties of weather location. Then I don't need this let JSON line anymore. I just kept that in there for reference. I'm going to delete that. I don't need it. Let's build and run and take a look at our results. Now our results are going to look a little wacky. First of all, the reason why we're seeing Africa up here is because this very first current location, I don't know if you remember this, but we append this dummy data, current location, latitude 0, longitude 0, as the very first element in our weather locations. So apparently 00 is someplace on the equator in Africa. Jamena is a city in Chad, so that must be that time zone. But then when we swipe, we see Gonzaga University and we see Georgia Tech. What's going on here? Well, behind the scenes, one of the things that iOS does is it will actually fetch the next thing in line as you swipe, so it's prefetching Georgia Tech. That's why we can see that we've got Gonzaga, which is what we're showing and we're looking at in our view controller, but we also have Georgia Tech, which is waiting in the wings. Well, instead of printing stuff out, why don't we go ahead and instead take the time zone value and show it in the date label of our view controller. Now, if we're going to do that, do you remember what we need to do with our getData call? Let's take a look over here in Local Detail View Controller in the Update User Interface, which is where we'll use the data we get from getData, and we're going to use that to update our user interface. So these lines that we have up here, date label, temperature label.text, summary label.text, we shouldn't be updating these until we're sure that we've got our data back from WeatherDetail. How can we be sure? Remember, from To-Do List, our friend the escape enclosure, we'll add an escape enclosure to getData. That'll let us put some curlies after getData that says, hey, don't execute what's in the curlies until you've gotten the data, and then we can put these 4 lines in those curlies. Let's make it so. So back in WeatherDetail, in getData, we no longer will have no parameters in there. We're going to have a parameter which is a closure. We'll say completed, at escaping, open and close parens, arrow, open and close parens. Now remember, we need to put in these completed signals any place where our code should escape. So I'll copy the keyword completed, and I'll first paste it before the return statement in the fail part of the guardlet here. Make sure you've got open and close parens after it. Now, I wouldn't return any data here, but I also wouldn't be hanging inside of my getData method waiting for a completed signal. And we should only need one more. I'll put it as the last statement in this closure that we execute after the session data task. So that's just before the curly that's on top of task.resume. And again, make sure that it's completed with open and close parens. And now we can return to location detail view controller, go down into update user interface, and just backspace over the 2 parens in getData, do a shift command K just to make sure Xcode knows that we made those changes. And we indeed see that getData now has a closure after it. Press return to accept that. And for the block of code in the closure, I'm just going to highlight these 4 lines up here from date label through summary label, cut them out with a command X, and paste them in with a command V. Xcode gets a little grumpy because we don't have selfs in front of the values inside of the closure, so we'll just add self dot in front of all 4 of these. And now let me ask you, can you guess what we need to do to avoid an error here? I'm going to build and run and show you an error right now, and you can take a look at the problem I'm going to have. Here's a hint. Take a look at the error that we're getting here in purple, and then pause and see if you can remember how to solve it, and then resume. Let's see what you came up with. So you can see the error says UI label.text must be used from the main thread only. Oh yeah, this is encountered when we were operating on the back thread, which is exactly what's happening. Remember, the escape enclosure says cook along in the background, and then you can perform this extra stuff when you're done. Well, the stuff in the background is in the background thread, not the main thread. The main thread is where you have to execute anything that deals with the user interface, like updating labels. So what we want to do is use dispatch_queue.main.async, put a couple of curlies in there, then take all 4 lines down here that are dealing with the user interface, put them in the main queue, and we won't get that error anymore. And so we're almost ready to put our time zone inside of our date label, but we're still running into a problem because if we type in WeatherDetail and then try to do a dot result to see if we can come up with that, hey, it's not showing up. Maybe you know why. Let's go over and take a look inside of WeatherDetail. Oh yeah, we haven't created a class property of type result. So when we use result, we declare it inside of the getData function. It's not declared as a class-wide property. Now the way that I'm going to get around this is not by declaring a result property, but I'm actually going to declare a time zone. So we'll just say var time zone, and we'll actually initialize this to an empty string. This way we won't have to worry about creating an initializer for this class. And then if we scroll down into our do catch, right after we get our result, we'll say self.timezone, which is the property I just created, equals result.timezone. I can just copy and paste it in here, and I'm going to get rid of this extra stuff that I was printing. I don't need that anymore. And now I can return to my location detail view controller, and we can say WeatherDetail dot, and you can do a shift command K to make sure that Xcode knows about your work. As we start to type in time zone, there it is. Press return. Now let's build and run and see, hey, it looks like we're starting to parse some JSON because I see current location shows the Africa Jamaica time zone. Let's swipe. Gonzaga has the Los Angeles time zone. That's correct. Gonzaga is in Washington State. Georgia Tech on the East Coast, they're the New York time zone. San Francisco State, they're the LA time zone. And Boston College is the New York time zone. Working well. Nice job, Swifter. Now let's finish this off with the temperature and the weather summary. So let's head back to our WeatherDetail class, and now remember, we've got to deal with that nested JSON, so we're going to have to create some more structs in here. Just a quick review from the previous slide, both temperature and summary are key pairs that are nested inside of keys, currently and daily respectively. So we've got to go currently, temperature, value, daily, summary, value. So the way we're going to do this is we're going to create a struct representing the innermost JSON. So a currently struct that contains a variable temperature and a daily struct that contains a variable summary. And then we'll add two properties to our struct that's one level up. That's a result struct. And so that's going to have a currently property that's of type currently and a daily property that's of type daily. And then we get at these values by referring to result.currently.temperature and result.daily.summary. Let's do it. So right under result, we have struct, capital currently, colon, codable, open and close curlies, and inside we'll say var, temperature, colon, double. And as always, you want to make sure that temperature is spelled exactly like the key in JSON. And right underneath this struct, we'll create our other struct. We'll say struct capital daily, colon, codable, open and close curly, var, summary, colon, string. Now let's create a couple of class properties to hold these values too. So we'll say var, lowercase temperature equals 0.0. And again, we'll initialize these to dummy values just so that we don't have to create an initializer. And we'll say var summary equals empty string. Whoops, I almost forgot. Inside of our result struct, we've got to create variables that are of these two types we just created. So right underneath var time zone, we're going to say var currently colon capital currently and var daily colon, that's of our new struct capital daily. Now let's scroll down into our get data. And right under self.timezone, we'll say self.temperature equals result.currently dot temperature. Shows up there perfectly. Right underneath that, we'll say self.summary equals result.daily.summary. Perfect. Let's also deal with this temperature. If we take a look over here, we can see that the temperature is coming back as a decimal, but I don't want to display decimals inside of my app. So I can deal with that in a few ways. We declared our temperature here if we option click on top of it as a double, but why don't we go up here and declare this temperature as an int? And the way that I'll do that is I'll just scroll up to the top, and instead of setting the temperature equal to 0.0, I'll just set it equal to 0. It will implicitly declare this as an int. Then back in get data in our do catch clause, let's take result.currently.temperature and typecast it to an int. So we'll put int in front of it and then surround result.currently.temperature in parentheses. And if you want to make sure that we round up or down, after temperature, we'll include the dot rounded method that you see here. Look what it says in code completion. It says that it performs schoolbook rounding. That means round up at 0.5 or above, round down below that. And then back in location detail view controller, we can go back into our code that's inside of the dispatch queue, and now we've got a real value we can assign to temperature label.text. So inside of this string that we had set up earlier, we just had 2 dashes for the placeholder string. So instead we'll replace those 2 dashes with string interpolation. Then we can put WeatherDetail.temperature right in there. And right below that, we'll set our summary label.text to WeatherDetail.summary. Build and run, and look at this. As we swipe through here, we can see the temperatures at different places. Chad is 61 degrees, Gonzaga 48, Georgia Tech 71 down in Atlanta, San Francisco State is 57 degrees, and it's a balmy 47 here in Chestnut Hill, Massachusetts. Swifter, you have just mastered JSON parsing. I hope you're feeling good about your continually growing skills repertoire. Keep at it.